want to continue because at least we can discuss something. Then you can have like something before I reach back Malaysia later. Okay. So the video that I shared before this, you already saw or not, all of you? The video that I shared in the morning, sempat tengok tak? You already watch or not the video?
Yes, sir.
Okay. So since this is actually what to call I sent this video, and then last time I sent the revision video in the discussion section on the e-learning also. Nobody asked any question. So hope you watch the video, and then if there is anything you ask me, then only the e-learning, I mean the blended learning will be effective, otherwise it will be very difficult. Okay, as for the two-part, we will discuss the example 1.1 that is actually from your slide. This is actually from the slide, and I will explain accordingly with the what I call the equation that will be given in your exam and test. So today we actually cover this two part. One is actually Z parameter, and then Y parameter. These two actually we covered. Okay, if you recall, for Z parameter, we will make the current of the port 2 here current and port 1 here current. We will do like that. There are two methods, sometimes they won't use the current elimination, source elimination method. Is directly find what to call that mesh. They'll do the mesh analysis by fixing V1 here, V2 here. They'll have like a 3 loops, and after the 3 loops you can get the I1 and Z11, Z21, Z12, Z22. You also can do like that. You'll rearrange the equation accordingly, VII, like something like that. Okay, that is actually one method. But if the circuit actually getting complex, that method won't be useful. Okay, and if you have like what to call a circuit with complex number I and J, okay, phase, so that is all actually will be very difficult. So therefore we will teach this method also. But in the exam, we don't mind. You can use any method. If you still want to use difficult method for a simple question, it's actually up to you. Okay, we don't mind which method you're using. But as for now, we will use the method that we plan to teach in this semester. Wait, I click record first. For this circuit, if you see the circuit, we will take the circuit, we will analyze accordingly. So first, you see, always use the equation. No need to memorize anything. V1 equals to Z11 I1 plus Z12 I2, and then V2 equals to Z21 I1 plus Z22 I2. Okay, to find Z11 and Z22, in the slide presentation, I mentioned that you have to eliminate I2. Okay, you have to eliminate I2, means I2 actually, I2 should get 0 value here. Wait for a while. Okay, I2 equals to 0 means here you need to make an open circuit, then no current flow here. And here you'll have a V1 as usual. Here you won't have a current flow since this is usually open circuit. So you need to redraw the circuit. Here you have to fix the source V1, here open circuit. So no current source. So when you redraw the circuit, I always like to redraw the circuit because the circuit looks simpler after you redraw. Okay, no I, no current, but we will have the still we will have the V2 across this resistance. Okay, that actually we will have 8 ohm. Wait, did I miss anything? Oh, I missed this resistance. 10 ohm. Twenty ohm. Okay, so this is V1. V2 still will have across the 20 ohm resistor. Okay, because voltage still can be measured even with the open circuit. Whether you draw a line like this or didn't draw a line like this, same you can measure the voltage. Okay, any questions so far? No question, we can proceed. So now we will what to call, we will get the equation in terms of I1, V2 and V1. I1 in terms of V1, I1 in terms of V2, then you can get the Z11 and Z21. Okay. So the easiest way is actually to get the V1, I1. I forgot to write the I1. I1 actually here, we have the I1. Okay. You actually can simplify the circuit like this, where this is 20 plus 10, actually you'll have a 30, right? So the next stage you will have like this. 30, 20, then 8. Okay. 8, 30 and 20 if parallel means what will happen to the circuit? Someone calculate and tell me the value. 30 parallel with 20. Mm-hmm. 12 ohm, sure. I'll trust you, because I don't have calculator here. So this actually will result in 12 ohm, as your friend said. Okay, anyone check, 30 parallel means 30 times 20, I think, divide by 60. Okay, 1 over 1 over R equals to 1 over 20 plus 1 over 30. Then after you calculate, you have to invert it. So this actually 12, and this plus this actually you will have like a 20 only. V1 I1. So from here you can get the relationship V equals to 20 I1, V1 over I1 equals to 20, which is this is actually equals to Z11. Z11 is actually what? When from here, if you see, when from this equation, V1 equals to Z11 I1. So V1 over I1 equals to Z11. Any questions so far? All clear? They ask,
Yes, sir.
if you have any question, just ask. I can repeat. I don't mind. Okay. If I did any mistake also, just inform me, if any calculation error or anything. Okay, now we already get the V1 I1, correct, on the terms of V1 I1. The next is actually we want to get the V2 in relationship with the I1. So in circuit, you could have like a various method. Various method can be used to analyze the circuit to get the relationship or anything. Up to you. Anything is actually possible. Okay, anything is actually possible for you to get the answer. It doesn't matter. Okay, so in this circuit, once I observe what we can do, we actually can either get the current divider rule, apply the current divider rule here to get the V2 also can. Okay, you can apply the current divider rule. You get the, for example, let's say you get the Ix over here. Okay, you get the Ix. Also, you can do the, but maybe complicated. Or you get what to call, you already get the relationship here, right? What is that? What is the V equals to 20 I1. Okay, and then you can get this V here. For example, let's say this is 12, right? You can get the voltage across this whole resistance here first, because it's actually 12, correct or not? Then you have to again divide the voltage to 10 to 20 also can be done. So there are two possibilities to get the answer. Okay, apart from that, is there anything else? Or you can do like a mesh also, two loops. You can do the two loops here, and based on the two loops equation, you can get the V2 and I1 relationship. Some method could be faster, some method could be slower, but regardless, your aim should be you do the analysis carefully. Yes. Anyone message anything? 12 ohm. Baru dapat. Bukan sini ya. Okay, I give you time to think. Okay, I give you time to think on what you're supposed to do to get the, because circuit analysis is actually important, I don't want you to give like a free food here. Just think again, looking at the three circuit, what you can get, what you can do so that you can get the relationship with V2 and I1. For now, I just prefer to use this, what to call Ix. Just we try with this method first, because this actually will take time. Okay, current divider rule, Ix equals to, the current over here equals to I1 multiply with this current multiply with over this resistance times with this resistance over this resistance plus with the resistance, total resistance on this branch 30, right? Ix, the current over here is equals to current over this branch equals to total current inserting the node I1 multiply with on the other branch, impedance on the other branch, divide by impedance on the this or total branch, impedance on the total branch lah. Total impedance on the branch 20 plus 30. So this actually will have like a I1 times 20 or 50 Ix, and V2 is actually what? V2 is Ix multiply with 20, correct or not? Ix multiply with 20. So Ix is actually, this is actually Ix 205 I1 times 20. Okay, sorry. So V2 equals to 8 I1 V2 over I2 equals to 8 ohm, which is Z21. Okay, this is using current divider rule. I use a current divider rule here so that I can get the current over this branch, and then this current multiply with the resistance here, I can get the voltage drop V2. Okay, so based on that, I can get the relationship between V2 and I2. Okay, the first Z parameter done, Z11 and Z21 actually already done. Any questions so far? Or you have any other method? Or if you use any other method also, you should get the same answer. Can I proceed with the next step? Okay, same again, we write again this equation V1, V2 equation for the to obtain the other parameter. V1 equals to V2 V2 equals to 1 I1 plus Z22 I2. This equation will be given in your exam. And based on your understanding, if I want to get Z12 and Z22, Z22, I need to eliminate I1, right? This is equals to 0. If equals to 0, then only I can get these two parameters. This whole thing actually will be eliminated. So first equation, you will have like V1 equals to Z12 I1, I2, sorry. Second equation, you have like a V2 equals to Z22 I2. Okay, from these two, I get the V1 equation and V2 equation. So what I mean by turning off Y1 0? I1 here, you have, this is the I1, right? This I1, you have to make the port 1 open circuit like this. Port 2, you have to close the circuit. P2. Okay, this is open circuit. So you cannot remove the resistor there because yeah, you know, not can, it can be removed because there's actually no voltage drop there because no current, right? Okay. So here, when you draw the circuit, it will be like this, where because no current here, no voltage drop, so you can ignore that one. 20. Oh yeah, not eraser not coming out. Can't use eraser. It's okay. So if I draw the circuit again, it will look like this simplified circuit after the circuit looks much simpler. V2 20 and 20. Here, this resistance you can ignore because no current, no voltage drop. So the whole thing you have like a V1, positive minus V1 across this resistance. And here I2, you will have the value. Okay, so here you can do faster because if you want to make a simpler circuit like this, it will be 30 parallel with 20. 30 parallel with 20 just now we did. Oh yeah, 30 parallel with 20 actually we did just now. 30 parallel with 20, it will result in 12 ohm. So V2, I2. So V2 equals to 12 I2. V2 over I2 equals to 12 ohm, which is Z22. Right, what I'm doing? Is there any mistake or anything? You just tell me, as in terms of calculation. The circuit, if you see the circuit, I open here, then I make a source here. Because why I want to open here? Because I want to make the I1 equals to 0. So the circuit will become like this: 20, 10, 20. Okay. These two can be series 30, parallel with 20, 30 parallel with 20, you will have 12. So become very simple circuit now. I can use V equals to IR, V2 equals to 12 I2, V2 over I2 equals to 12 ohm. Okay. So we still can use the same principle like just now. I can get the Ix, then I can get the voltage drop to get the V1. Okay, can be done as well. So here the Ix is I2 multiply with this branch 20 over 30 plus 20. So I2 times 2 over 5 Ix. I get the same value lah. Is it reciprocal? I macam tersilap ke mana-mana. Anyway silap lah. Yes, no, 20. Okay. Okay. I 20, 30 plus 20. Okay, correct. Then V2 is here. V2 is actually Ix. Sorry, not here. V2 not here. The V2 over here, not V2. V1 over here is actually Ix is actually V1. Only this part. V1 is actually Ix times with 20. V1 equals to Ix times with 20. What is Ix? 2 over 5 I2 multiply with 20. V1 equals to, so V1 over I2 equals to 8, which is Z12. Okay. Any questions so far? I also will do with the what you call the other method though. I believe in circuit 1 you use the other method, the full loop analysis. Use the full loop analysis, right? Those who take circuit 1. Those who didn't take circuit 1, it's a different story. You use this method or not? Full circuit analysis. I have the loop, 3 loop. You'll put a 3 loop. But for this circuit, actually very too complicated, 3 loop. Simple circuit, okay. I don't want actually. I'll show the one for simple circuit. For this, I don't want. Because it will have a 3 loop, then the analysis become very bigger. Too large. Any question, guys? Anyone cannot understand any area? You can ask me before we go to the next example. All okay, huh? Sure. Don't play around, later exam time, test time, they cannot do. I can't help. Wait for a while. I stop presenting first. I search the slide first. So this is actually second question. We do this one also. This is example 1B. I have a different name. Example 1B. B from the slide. Do we have example 1A? Oh, this is 1A. I put 1.1. Okay, so for example 1B, you're also going to find the Z parameter. Okay, always refer to the table. Don't act too smart. Make it as a practice, using the table so that you don't need to memorize the answers. So here, for the circuit, we need to find the Z parameter. So here you will have like a V1, V2, I2, sorry, I2, I1. So again, we will write the same thing for first case, V1 equals to Z11, I1, V2 equals to Z21, I1. For the case of this one, actually 0. Okay, we make it like a faster now. Okay, so I2 0 means here open circuit, here close circuit. So you have like this. V1 20 ohm, 40 ohm, and here, since this is open circuit, this resistance won't be effective. So V2 only here. Okay, plus minus. Okay, so the total resistance here, I mean total current here and total resistance can be give the V1 I1 relationship. V1 equals to 60 I1, V1 over I1 equals to 60. Done. This is actually Z11 because the circle actually is simple. And then V2 equals to I1 times 40. V2 equals to I1 times 40, correct or not? 40 I1. V2 over I1 equals to Z21, which is 40 ohm. Done. Because the circle actually easier. Okay. Circle complicated, then the analysis might be complicated. For the second part, okay, for the second part, when you want to make the, what is that? This is 0, then you will have like this. P1 equals to Z12 I2, V2 equals to Z22 I2. So in this case, what we will do, we will actually we will put the source here, V2 here, and here we open circuit. So this is actually will be eliminated. You only have V1 and you have I2, I1 0. So no current flow here, no voltage drop. So this can be ignored. Okay, so in this case, is that V2 equals to I2 multiplied with the total resistance, which is 70. So V2 over I2 equals to 70 ohm. This is actually Z22. And then I2 times 40 is actually V1. V1 equals to 40 I2. So V1 over I2 equals to 40 ohm, where this is known as Z12. Okay, this is simple circuit, so not so difficult to analyze. And this circuit we can try with what we call that loop analysis. Like the maybe some of you use the old method like this, where you don't follow the equation, you just get the relationship according to the equation, then you compare the equation with what your equation and you extract the Z11 and Z21, 20, 40, 30. So this is actually 20, 40. Usually I won't use this one. I won't recommend because this is okay for simple circuit but difficult for complex circuit. V1, V2. Okay. So for this case, correct, huh? Circuit correct, right? 20, 30, 40. Yeah. So I can have a loop like this. This is actually I1, right? I1, this is actually I2. So I can have a loop like this, I1 loop like this, and I2 loop like this. Okay, I1 and I2. Okay, for this direction, for this first loop, loop 1, V1 equals to 20 I1 plus 40. Here both current actually combine together, I1 and I2. I1 and I2 direction, because same direction, so I1 and I2 actually combine together. Sorry, finish line. This is the first loop. Okay, so you just rearrange the equation so that you can tally with this original equation here. Okay, rearrange the equation. You separate I to one side, B to one side. Okay, we do the one later. We go for loop 2. Okay, V2, we go for the second loop. V2 equals to 30 I2 plus 40, same direction, current direction. This will become total I2 plus I1. Okay, now we rearrange the equation so that you have V I1 I2. V I1 I2. So here you have V1 20 plus 20 I1 plus 40 I1, 60 I1 plus 40 I2. And here you have V2 equals to, you write I1, I1 first, 40 I1 plus 70 I2. So this is actually, now this is actually Z11, Z21, Z12, Z22. Okay, according to the equation, just compare Z11, Z12, Z21, Z22. Okay, so this is actually Z11, Z12, Z21, Z22. Okay, you compare back with our answer. Z11 60, Z21 40, Z21 40, and then Z1 to 140, Z12 where? Mana Z12? Kita cari ya. Here, Z12 40, Z22 70. Same answer. The loop also easier if the circuit actually simple like this. But if the circuit actually complicated, 3 loop or 4 loops, better follow the elimination method. Otherwise, you're going to suffer. Okay, I've seen like some student, and especially when you have like a dependent source, this and that, don't use this. I'm not saying that you cannot use loop method. Don't keep the source like this and then do. You can use the loop method in the simpler analysis like this. But at the end of the day, that's my advice. If you feel comfortable with any method, you just proceed. I don't mind. I know how to. I know about both all method. I still can mark you and give you marks. Any questions so far from the crowd. Sorry, really sorry for the what to call